So now that we've gotten some of the kind of basic foundations of how cryptocurrencies work, what a blockchain is, some of the history behind cryptocurrencies, I wanted to quickly give you an overview of the three main cryptocurrencies. And don't worry, I'm going to go into their own separate sections, but I thought it's valuable at the top of this course to just give you an idea of, hey, what are these three different cryptocurrencies that are currently leading the market? And uncover just some of the differences between them because they each have their own unique identity in the crypto space. And the first one is Bitcoin. Bitcoin is the pioneer of that decentralized ledger technology where you're writing those transactions to a public blockchain in a linear chronological order using proof of work where you have those miner computers that are solving really complex mathematical puzzles that'll validate transactions and then create new blocks of transactions. And something that really separates it from the other two cryptocurrencies I'm going to talk about is there isn't really a scripting language for you to write applications on top of Bitcoin. There are a lot of people that are working to design new ways to do that, but the reason behind that initially is they wanted to limit the ability of how you can interact with Bitcoin to ensure security and simplicity for it. Because that leads me to kind of the key feature and use case of it is that it is really just supposed to be valuable asset like cash, gold, or real estate. It's just kind of meant to sit there and accrue value and become more valuable so that when you want to take it out, you have more as the same or more value than you put in. Obviously, that hasn't always been true, especially if you buy at the peak of the cycle. But that is kind of its main use case and what draws a lot of people to Bitcoin. With proof of work, with the need to actually have all these miners, it has a really robust security model and a really high degree of decentralization, which makes it, a relatively trusted and stable digital currency because the network is so decentralized across the entire world. There's not, one person that's running most of the network that it's very hard for, one person or a group of individuals to actually take over the network and influence it. However, some of the limitations of Bitcoin are, it's really slow. The throughput is limited to almost 7 transactions per second. So there can be high network congestion, higher transaction fees, because when a network is really congested, and this applies to Ethereum and to a lesser extent Solana, you have to pay more for your transactions to be recognized immediately because the miners will only include the transactions in a block that are paying them the most because miners are selfish and they want to make the most money. And also because you have to run these physical computers, you have to solve these really intense math problems, the proof of work consensus mechanism is super energy intensive, which has raised environmental concerns around a lot of people. Some people view that as a strength, some people view it as a weakness. Now, the next one I'm talking about is Ethereum. So Ethereum, and the big difference of it from Bitcoin is that it not only records transactions, but also hosts smart contracts. Now, a smart contract is really just a piece of code that's hosted on the Ethereum blockchain that is self-executing. So if I call or send money or say trigger this smart contract, this piece of code, that piece of code will always function in the same way because it has been enshrined in the Ethereum blockchain. So similarly to how in Bitcoin, you post a transaction, then you can't change it. Smart contracts, you create them. So you write your script in Solidity, which is the Ethereum programming language that allows you to write smart contracts. And we're going to have a whole section on what smart contracts are and how they kind of work because it's important for understanding Ethereum. But just at a high level, just think of them as a code script that is always going to run and no one can change it without you being able to see it. You can see what the code you're executing is going to be. And this enables things like applications where, let's say I have an exchange and I want to pay 2 Ethereum to my friend Bob over here, right? So I made this money and I want to share it with Bob. What I can do is interact with a contract that will facilitate that exchange. So this EVM box here, imagine that the Ethereum virtual machine is what this stands for. And so with the Ethereum virtual machine, this is where you're going to be host your Solidity code, that is scripts you run within the Ethereum virtual machine. You can think of that almost like an internet computer. It's running across all of these different compute nodes. So similar to Bitcoin, you have many different compute nodes, many different people running computers that are helping to run the Ethereum blockchain. And so when I interact with this contract, this Solidity smart contract, to send money to my friend Bob, what I'll do is I will put 2 Ethereum into the smart contract. That smart contract and Bob's address, so his wallet address. Every person in Ethereum, you have a wallet that has a unique address that is generated by 12 or 24 words being fed into a crypto hash, which then generates the wallet address. I put in Bob's address, my 2 Ethereum, and then the Ethereum virtual machine will post that transaction, take my money, move it through that smart contract, and the smart contract would say, hey, take X amount of Ethereum, however much they're adding, and send it to whatever address they're sending it to. And then that transaction, so the value change from taking 2 Ethereum out of my wallet, giving Bob's wallet to Ethereum, goes through the Ethereum distributed network. And then that transfer of value, that application, that state change, is enshrined within that block. So similar, again, to Bitcoin, you have blocks of information, but in this case, it contains smart contract operations, not just transactions. And so this enables, this was a very simple example, but there's other examples like, hey, what if I want to have a game running on Ethereum, right? You actually can have that because at the end of the day, every piece of action you're taking on a computer is really just a state change. When I swing a sword in World of Warcraft, that is my state changing from not attacking to attacking, and then once that sword swing is done, going back to not attacking. And so those are the kind of contracts you can write, and then use Ethereum to actually take those actions and publish them to the blockchain. Use that worldwide computer to say, hey, now everyone knows that George swung his sword or transferred money to Bob, and that is completely enshrined there. So there's no like saying, oh no, I didn't mean to send money to Bob, or this was a scam. It's no, you signed the smart contract and then transferred the money to Bob, or you swung that sword. Now, the key difference from Bitcoin, that is actually a pretty recent change, is that Ethereum now uses a proof of stake network. And so that means that instead of you actually, you have your computer running and doing all these complex math calculations, now you just have a computer that is assigned 32 Ethereum. And so every computer on the network has to have 32 Ethereum assigned to it. And then all they do is they just take those state changes. They find, hey, has there been a state change? Has someone tried to write a contract? Every time a block fills up with new transactions, the Ethereum network publishes that. One node gets selected to actually publish the block, and they get extra rewards for that. So these miners, which aren't really miners, they're proof of stakers, I guess, to use a really ugly analogy, they will publish this to the blockchain, and then the way they guard against, someone coming in with a bunch of computers and saying, I want to take over the network and just publish all these transactions that give all the money to myself, they can't do that because 32 Ethereum is around $64,000 right now, and you would need almost $125 billion to have a significant share of the network that you could actually take over and publish your own transactions and basically be in control of Ethereum. So it becomes financially infeasible for someone to do so. And because you have kind of all these options for how you want to write programs, you're not just restricted to posting transactions. You can actually create applications, use Ethereum as the backend compute for those applications. Ethereum has a massive active developer community, lots of different applications that you can use. It's where NFTs came out of. It's where decentralized finance came, where instead of me needing to go to Fidelity to buy some coins, I can actually buy coins from a decentralized exchange, which is an exchange that's run by many different people who have all pooled their money to then sell to me. And there's a lot of complexity there, but what I really want you to take away is that Ethereum enables a lot of higher level applications and more advanced use cases than Bitcoin. However, with all these new use cases, there are some scalability challenges. And let's say that analogy of me wanting to swing the sword. Well, if you want to publish that state change on the Ethereum blockchain, that's going to cost you a few dollars. And if you have a bunch of games that are trying to do that, the cost is only going to go up. And you're going to be, just for me to walk through a world in World of Warcraft, it could cost hundreds of dollars, right? And so because there's so many developers, so many people that want to use this network, so many people that want to develop on top of it, there are issues with congestion. There are issues with the costs for me to even do a simple transfer. Let's say I just want to send my money to Bob. that can cost hundreds of dollars, even if I'm just sending, $50. If there's a lot of people using it, because then the network fees will spike. Because similar to Bitcoin, if you want to get your transactions published first, you can pay more and then they'll get published first. So there is a lot of currently, a lot of issues and things around scalability that the Ethereum developers are really trying to push forward. But interestingly enough, that's where our next cryptocurrency, Solana, comes in, where it offers a really high throughput solution to a lot of Ethereum's issues. So Solana is a relatively recent entrant on the scene of cryptocurrency, and it really came in with the idea of, hey, let's create a network that can support over 50,000 transactions per second with really low transaction costs, which makes it really attractive for high frequency applications. If you're a trader that wants to be constantly trading back and forth, if you're on Ethereum, it's going to cost you a lot of money and get transaction fees. Versus in Solana, it's only going to cost you like a penny per transaction. And they have a hybrid consensus model, so separate from Bitcoin's proof of work, Ethereum's proof of stake. Solana actually has proof of history, which is a combination of miners that are, or not miners, but computers that have put up X amount of Solana. I think it's like 1,000 Solana, and then also they have proof of history. And so what proof of history is basically a function that is enshrined within Solana called the verifiable delay function that generates the timestamps for each block in the blockchain. And because there's so many transactions within Solana, this function is always firing. It has to constantly update and create new timestamps for every block that is created within Solana. And it's very computationally intensive. All of those computers need to be running this. They need to constantly be verifying the timestamps generated by VDF. And because it's complex, it's a very complex program, makes it really hard for attackers to actually get in there and manipulate the timestamp, because by the time they figure it out, it's already been created, the block's created, it's enshrined within the blockchain. And it also really just makes it easier to verify, to say, hey, this VDF is always going to come out with a certain outcome or a certain timestamp for this period, and it's really hard to fake that. Similarly, to how you have that unique hash within Bitcoin that's created from the proof of work. Proof of history has a similar function where, hey, this is so difficult to fake, borderline impossible, that it's just not even worth trying for any hackers trying to attack the network. They also have a lot of new features, and you can kind of see it's like got almost a nautical theme, where you have something called sea level, which allows you to have parallel smart contract runtime. So let's say in Ethereum, if you have a smart contract and you have many people trying to interact with it, there'll be a queue of people that are allowed to interact with the smart contract that are executed sequentially. Versus Solana, you can have a smart contract that is interacted with by many different people at the same time. And then you also have Gulfstream, which forwards all transactions to the validators immediately. So just, again, faster throughput of saying, hey, this transaction is created, immediately go send it to a validator and validate it. And a lot of these improvements, and you can see it has archivers, just a lot of things that can really speed up Solana's throughput and enable it to have those low fees, because it's able to process so much data in a single block. And this has really led to Solana kind of becoming an up-and-comer contender with Ethereum for being the hub for DeFi projects and Web3 applications, because it's so much cheaper for you to actually run your applications directly on Solana. However, because Solana, it has these really computationally intense VDF functions, you have to put up a lot of Solana to actually run a validator and make money off of it. There's quite a degree of centralization. There's much less decentralized nature of the validators, the people that are actually running these nodes to support the Solana network. And it also, just because it's kind of a newer network, it has experienced several network outages. And so people have a lot of questions about robustness and reliability. But almost the reason that people bring those up, or the defense Solana has that, is, hey, we're moving fast, we're trying new things, we're breaking things, versus Ethereum takes a very slow and measured way of introducing new technology, new concepts into the Ethereum blockchain. But these all represent significant milestones in the evolution of blockchain technology. Bitcoin was really that pioneering force that opened up the whole world of digital currencies. Ethereum, really introduced the idea of smart contracts, centralized applications, having this kind of world computer. And then Solana has really kind of built on top of what Ethereum had and is a scalable solution for really high throughput demand applications. And I'm not even going to bother getting into the choice, which one's best here, because that's what we're going to do in the rest of this course. So, give you a framework for identifying, hey, these are the blockchains that I think are most valuable and that I want to invest in. And the choice between these platforms really depends on the needs of, what you want to get out of them. If you want a static store value, go to Bitcoin. If you want to create really, complex, easy to use smart contracts, go to Ethereum. If you need really, really high throughput, you need to be posting transactions super fast, use Solana. And so as this continues to evolve, maybe there's new contenders, maybe this top three expands to top four. But these are really the three main cryptocurrencies out there right now that I wanted to kind of talk about at the start of this course. But in the next lesson, we're going to go over altcoins, which is really just a fancy term for cryptocurrencies that are a little further down the list of market cap and really just market share. So stay tuned for the next course episode for more on that.